In this video, I'm going to show you how to create a Proxmox 8 cluster using 3 nodes. In this case, I'm using 3 HP mini PCs, and if you haven't seen my previous video, I'll link it up here. I show you how to install and set up Proxmox. So without further ado, let's jump right into it. So I have prepared 3 nodes here. This is just called PVE1, PVE2, and PVE3. First thing we do is we log in. So this is the root account that you created during the installation process. It's normal that you don't have a subscription, but we're using the community edition, so the repos are already set up on these nodes. We need to create a cluster, and I'm going to use PVE01 as the master of the cluster. We're going to click on data center, and then we're going to click on cluster, and then we're going to create a cluster. So create cluster. Here, the name, you can put anything you want. I'm going to put PVE cluster. And the network that we're going to use is the network of the node. Perfect. So we're just going to click on create. Okay, we see that all the tasks were okay. So now we can close. Now we need to extract the join information. So we click on join information, and it's going to give us basically the API key that we need to use in the other nodes so that we can join. So we're going to click on copy information. Now we're going to go to our second node. Now we're going to go back to data center. We're going to go to cluster, and then we're going to click on join cluster. Here's where we paste our join information from our previous node, and we need to input the root password of node 1. Perfect. Now we click on join PV cluster. While this one is joining, let's do the third one. Now we click on data center, we click on cluster, then join cluster again, and we copy our join information. We put the password of node 1, remember, we click on join. Okay, so it says join request okay. Now we can close. You might see this error here, but it's normal. We lose connection to the nodes for a few seconds, but all you need to do is refresh. We refresh this one too, the third one. Okay, we can click on advance and proceed. Don't worry about that warning. Put in the password again. And now, as you can see, we have 3 nodes in our data center. It doesn't matter which node you connect to. It can be node 1, node 2, or node 3 web UI. You're going to be able to manage the entire cluster from any of those web UIs. So as we can see, we have the 3 nodes here, 3 nodes, and we have our 3 nodes here too. So at this point, we already have a Proxmox 8 cluster, but we want this cluster to be HA. HA stands for high availability. And to do that, we need to configure Ceph. Ceph is basically a shared storage that the 3 nodes are going to use to run VMs. This will enable us to migrate VMs from one node to another without any downtime. Or in the case that one of your nodes fails, the VM can be automatically restarted in a new node. So let's configure Ceph. The first thing that we need to do is install Ceph on the 3 nodes. And to do that, we're going to go to node 1. We're going to go down to Ceph. And as soon as you click on Ceph, you're going to get a message telling you that Ceph is not installed. Would you like to install it now? We're going to click on install Ceph. Now, if you have a subscription, you can use the enterprise repo to install Ceph, but in this case, we're using community, so we're going to change the repo to a no subscription. Now we're going to click on start Quincy installation. This is going to go and fetch all the packages that we need to install. Here, we just need to click on Y to say, yes, you want to continue. Yes, we want to continue. And it's going to install all the packages. Okay, as you can see, install Ceph Quincy has been successful. Now we can click on next. Now the configuration. In an enterprise environment, you would want to have a second network only for Ceph. Ceph needs low latency and very high throughput to keep all the disks synchronized. In this case, I'm going to use the same network as the host just because I don't have a separate network for that. But for our demo and for our environment, it should be good enough. So now here we can click on the network that we want to use, which is the local network of the node. And then for number of replicas, we're going to go with the default, which is 3 number of replicas and have at least 2. Okay, now we can click on next. And as you can see, the installation is successful. Of course, there are a couple of steps that we need to finish so that we can have Ceph up and running. I'm going to go through the installation on the other nodes. I'll be right back. Okay, so now Ceph is installed on all three nodes. The next thing that we need to do is we need to configure the OSD. What OSD means is we need to select the drives that we want to use for our Ceph configuration. In this mini PC, I have a 500 gig SSD that I'm going to dedicate for Ceph. This is replicated on each of the nodes. So I have 500 gig SSD on each one of them. So let's now configure the OSD. We click on PV01, we go down here and then we click on OSD. And here we're going to create OSD. Okay, so as you can see, it automatically detected my drive, which is the only drive that is available. If you have any partitions or anything on this drive, just make sure to wipe them and delete all the data and all the partitions. That way, Proxmox will be able to recognize it. So now we can click on the drive. And here, basically, there's nothing else that we need to do. We're going to leave all of the settings by default. The defaults are pretty good. So now we can click on create. So now that's creating OSD and OSD on SDA. Okay, so we click reload. We can see that one of our drives is there. Now we're going to go to PVE02. We're going to do the same, create OSD. We're going to select our 480 gig SSD and we're going to leave everything by default and create. Just give it a second for it to load and to configure the drive. And if we reload, we can see that now we have our second drive here. Now we're going to go through a third one, PVE03, create OSD, same drive, and we can click on create. Click on reload. And as you can see, we now have 3 OSD drives, one in each of our nodes. So now the next step that we need to do is we need to create a pool. Basically, a pool is going to be the shared storage that the 3 nodes are going to use to store the VM disks. Let's go to PVE01. Go down to Ceph and then we click on pool and then we click on create. And the name of the pool can be anything, but I'm just going to call it PVE storage. And the same defaults apply. Size of 3, minimum replicas of 2, and the rest can be left by default. So now we're going to create our pool. Okay, so now we have a PVE storage pool. This is the place where we're going to create all the VMs that we want to have high availability. This, you only need to do it on one of the nodes. And as you can see, if we open the other nodes, the PVE storage is there. You can see PVE storage on node 3, on node 2, and on node 1. Now, the last component of the cluster that we need to set up for Ceph is the monitor. The monitor is basically a node that is just checking all the components of Ceph and making sure that all of them are working properly, that all the data is being synced correctly, and that any part of the Ceph environment is functional. By default, there's only one monitor. So if we go here to PVE01 and then we go down to Ceph and then we click on monitor, you can see that PVE1 is the only monitor at the moment. We want to have more than one monitor because in the case that PVE01 is the node that fails, then our Ceph configuration or our Ceph syncing is not going to be able to check for everything. So if node 1 fails, basically what happens is node 1 is hosting the monitor, the data is going to be out of sync and then it could get very messy. So that's why we're going to add a monitor to the 3 nodes. To do that, we're going to go to node 2. We're going to go to Ceph and monitor again, and then we're going to click on create. We're going to create a monitor on host PVE02. Yes, that's what we want. So we click on create. And that's good. You can see PVE02 is there. Now we're going to go to PVE03 and we're going to do the same thing. We're going to click on there and then Ceph and then click on monitor. Then we're going to click on create and select PVE03 and create. So now for the fun part, we're going to migrate one VM from one node to another, and we're also going to simulate the failure of one of the nodes. And we're going to see how resilient this cluster is. Okay, so let's start with the first demo. We're going to migrate one VM from node 1 to node 2. In this case, it's just a Rocky 9.2 Linux VM. To see how efficient this migration is, we're going to start a continuous ping and see whether the machine goes down or not. First, we need to know what's the IP of the machine. So we're going to log in really quickly here. Let's check for the IP. So it's 192.168.0.219. So we're going to start a ping for that. So now let's start a migration. To migrate, we need to click on our VM here, and then we're going to right click on it, and then we're going to click on migrate. And we're going to say the target that we want to migrate to is PVE02. So we're just going to click on migrate. Let's monitor our ping here. Okay, so migration is completed. And as you can see, we didn't lose any pings, or the machine was seamlessly moved from one node to another. We can see here a little bit that the latency increased a little bit. So now if we go back to our Proxmox cluster here, now we can see that our VM is running on PVE02. There's no downtime. If we check the uptime of the machine, it's still up. So this is how a cluster works. We can move VMs from one to another. Okay, so now for the second demo. In the second demo, we're going to simulate a node failure. We're going to completely turn off or force shut down one of the nodes to simulate a failure, and we're going to see how long it takes for the Proxmox cluster to bring that VM back in another node. Before we do that, we need to configure the cluster or the data center to know which VMs we want to have on HA or high availability. So to do that, we're going to click on data center, and we're going to go down and click on HA, and here we can add resources. Resources means like containers or VMs or anything that we want to have in HA. So we're going to click on add, and we're going to click on VM, and we're going to click the VM that we want to have high availability, and request state it needs to be started. So we're going to click on add. By doing this, now our Rocky server is marked as a high available VM. Now we're going to simulate a node failure. Right now the VM is running on node 2. We're going to simulate a node failure. I'm going to start a ping here of 192.168.0.219. Okay, so we're pinging our VM. I'm also going to start a timer to see how long it takes the cluster to recognize that one of the nodes is down or failed, and how long it takes to bring back the VM. Let's go into PVE2, let's go on the shell, and we're going to completely force shut down this node. So for that, we do power off, and then we do -- force -- force, and this will kill node 2. I expect our VM to completely stop pinging on here, and let's go. Okay, so the VM stopped. Let's start the timer, and let's see how long it takes for the VM to come back alive. Okay, so we can see now in PVE01, we have our VM there. Is it pinging? Not yet, but it's starting. We are at a 3-minute mark. Okay, let's see if we can see something. Oh, and as we can see, the VM is booting back up into PVE01 without user interaction. It took around 4 minutes for the VM to come back online. Usually the time of how fast this happens, it depends on the type of failure, and I also think it depends on your hardware and the speed of the network of your Ceph cluster drive. My configuration is just a 1 gig and it's a shared network. In this demo, it might be longer, but in an enterprise environment, this can take up to 2 minutes and not 4 minutes. But as you can see, we have a high available cluster and a fault tolerance cluster 2, where our VMs can spin up back again in another node, even after one of the nodes is completely lost. And you can migrate VMs from one node to another node without any downtime. So with this, now we have a high available, fault tolerant Proxmox 8 cluster running on 3 nodes. Thank you for watching, and if you enjoyed this video, make sure to give it a thumbs up and subscribe to the channel if you want to see more content like this. Leave any questions or suggestions in the comment section below, and I'll see you on the next one.